Welcome students, we've been given x squared negative y squared is equal to 9 and xy is equal to 3. We expected to find x positive y. Now I will be doing this question in 3 different ways and let's get started. So foremost I will be using the algebraic identity which can be written as x positive y raised to the power 2 negative of x negative y raised to the power 2 is equal to 4 times xy. Now just in case if you are unaware what exactly happens, let me just show that to you. If I were to expand this will give me x squared positive y squared positive 2 times xy, and if I were to expand this is going to give me negative x squared negative y squared positive 2 times xy. So clearly x squared, y squared gets cancelled, giving me 2xy added with 2xy. So that's why I can use this algebraic identity. Now what I wish to do is, I wish to let x positive y be equal to some a. Now I'm taking this in order to solve the system. So if I were to take this as 1, therefore I can rewrite 1 to be as, in place of x positive y, I'm going to substitute the value a. Now before I could do that, I would also like to use x squared negative y squared is equal to 9. This has been given, right? Now I can rewrite this as x negative y multiplied with x positive y, which is equal to 9. Now from here I can rewrite x negative y to be as 9 over x positive y. So that means if I were to take x positive y is equal to a, this is going to be 9 over a. So that is fair enough. So as I mentioned to you, 1 can be rewritten as, this is going to be a raised to the power 2 negative x negative y is 9 over a, so it's going to be 9 over a raised to the power of 2 is equal to 4 times. Now xy is equal to 3, so I would be substituting that value. Now this can be further rewritten as a squared negative 9 times 9 is 81 divided by a squared is equal to 12. Now I will be multiplying throughout by a squared. Why am I doing it? I need to get rid of this denominator, a squared. So that would mean I would now have a raised to the power of 4 negative 81 is equal to 12 times a squared. Now I can bring this 12 times a squared to the left. That would mean I would now have a to the power 4 negative 12 times a squared negative 81 is equal to 0. So this is what I've got. Now what I wish to do is, I would have to take a squared to be equal to some t. So in that case, this can be rewritten as, let me rewrite this first as a squared raised to the power 2 negative 12 times a squared negative 81 is equal to 0. And this is going to be rewritten as, in place of a squared I'm going to have t, so it's going to be t squared negative 12 times t negative 81 is equal to 0. Now this is a quadratic equation, so I have t is equal to negative of negative, that's going to be positive. I'm using the quadratic formula. So in case if you are wondering what is the formula, if I have a quadratic equation of the form ax squared positive bx positive c is equal to 0, then x is equal to negative b plus or minus root of b squared negative 4ac divided by 2 times a. This is the quadratic formula I'm employing here, with of course the value of a in this case is 1, the value of b is negative 12, and the value of c is negative 81. So with that, this is going to be positive 12 plus or minus square root of, this is going to be negative 12 raised to the power 2 negative 4 times a times c. I already have a negative sign, so let me place that, divided by 2 times of 1. Now if I were to rewrite this is going to be equal to 12 plus or minus root of 12 squared is 144. This is going to be positive 4 times 1 is 4, 4 times 8 is 3, 2 divided by 2. Now if you were to add 324 with 144, you will get 4 plus 4 is 8, 4 plus 2 is 6, 3 plus 1 is 4. So you're getting 4, 6, 8. Now let me write that down. So this is going to be 12 plus or minus root of 4, 6, 8 divided by 2. Now I'm going to rewrite this as 12 plus or minus root of, now 4, 6, 8 can be rewritten as 4 times 117 divided by 2, because if you were to multiply 117 by 4, let me show that. 7 4s are 28, 2, 4 ones are 4, 5, 6, and 4 ones are 4. So you're getting 4, 6, 8. So this is equal to, now I can rewrite this as 12 plus or minus root of 4 square root of 117 divided by 2. Now this can be further rewritten as 12 root of 4 is going to be 2, so plus or minus 2 times root of 117 divided by 2. Of course I can rewrite this as 6 plus or minus root of 117. Now 117 can be actually fragmented. How do we fragment? Let me show that to you. Now 117 is actually 9 multiplied by 13. So 9 times 3 is 27, 2 9 ones are 9, 10, 11. So I'm going to rewrite this as 6 plus or minus square root of 9 times of 13, which can be rewritten as 6 plus or minus root of 9 times root of 13, which is rewritten as 6 plus or minus root of 9 is going to be 3, and that has to be followed by 13. Of course, that's root 13. Now all of this is nothing but the value of t, right? But t is what? But t is equal to a squared, isn't it? We have taken t is equal to, in fact we have substituted in place of a squared t, so we got to revert it. So this is going to be a squared is equal to 6 plus or minus 3 root of 13. Now we are expected to have a, so let me rewrite that. So therefore the value of a is equal to square root of, I'm moving the root out, that's followed by 6 plus or minus 3 times root of 13. So this has to, see, once you take square root, say for example you got a squared is equal to 36. Imagine, and if you want to get the value of a, this is going to be plus or minus root of 36. So we need to have that plus or minus there. So this is the solution. Now depends on the requirement of the question. The question wants us to find the value of a. So what should be the value of a? Now clearly we have taken, if you were to observe here, x positive y is equal to a, right? So this would mean you have to revert it back. So this would mean x positive y is equal to plus or minus root of 6 plus or minus 3 times root of 13. Now of course there might be some contention that this has to be only positive and so on and so forth. I leave it to the audience. So this is one particular way, and I'm going to show you another way. So students, now I will be doing the same question in another method. So this is method number 2. So foremost what I would do is I would just take x squared to be equal to some a and y squared to be equal to some b. Now this would mean x squared negative y squared, which is equal to, this is already given, right? X squared minus, so therefore given, okay, x squared minus y squared is equal to 9 becomes, this is given in the question. So this is going to be a negative b is equal to 9. So this is what we have got. Now using algebraic identity, what is that? We know that a positive b raised to the power 2 can be rewritten as a negative b raised to the power of 2 positive 4 times ab. You can check it out. If I were to bring a negative b raised to the power 2 on the left and add it with a positive b raised to the power 2, I would be getting 4 times ab. That's it. So now what I want to do is I want to obtain, or I should say place in the values of the quantities that I find here. Now clearly we have got a negative b is equal to 9. So let me place that. That's going to be 9 squared positive 4 times ab. Now the value of ab is actually, we have taken a to be as x squared and b to be as y squared. So let me just evaluate the value rather than placing the value of ab in terms of x. So let me just put it the value. So a times b is actually x squared times y squared. Now which can be rewritten as x into y raised to the power 2. But we are given that xy is equal to 3. So this would mean our AB will be equal to 3 raised to the power 2, which is equal to 9. Right? So this is my value of AB. So let me substitute the value of AB there. So this is going to be 9 times 9 is 81 positive 9 times 4 is 36. So let me just add 81 with 36. 6 plus 1 is 7. 8 added with 3 will give me 11. So this is going to be 117. So on the left, I've got a positive b raised to the power 2 is equal to 117. So therefore, I can write, actually it's a positive b raised to the power 2. So is equal to 117. So from here, a positive b is equal to plus or minus root of 117. So this is the value for a positive b. Now, the quantity a is x squared, quantity b is y squared. So this would mean I got a x squared positive y squared is equal to plus or minus root of 117. This is what I've got. Now what I'm going to do is I want to add positive 2 times x y both sides. Now if I do this, then this is going to be x squared positive y squared positive 2 times xy is equal to, I'm going to place 2 times xy over here, so it's going to be plus or minus 117 positive 2 times x into y. So this is what I've got. Now x into y, clearly we know that x into y is 3, so this is going to be plus or minus square root of 117 positive 2 times of 3, which is going to be 6 plus or minus root of 117. So on the left, this is going to be x positive y raised to the power 2, and which can be rewritten as x positive y. Now if I were to take this 2 on the other side, it will become a radical sign. So this is going to be square root of 6 plus or minus. Now 117, I'm going to write 117 as 9 times 3. Of course there is a square root, so this can be further rewritten as root of 6 plus or minus 3 times root of 30. So this is the value that is required, and we have obtained this. So this is method number 2. So students, this is the third method I wish to show you. So let me write that down. Method 3. Now what I'm going to do is I'm going to consider the given question. So we've been given x squared negative y squared is equal to 9. So I will be squaring both sides. So squaring both sides, we get, so this is going to be x squared negative y squared raised to the power 2 is equal to 9 squared. Now if I want to expand this, this is going to be x to the power 4 positive y to the power 4 negative 2 times x squared y squared is equal to 81. Now this is rewritten as x to the power 4 positive y to the power 4 negative 2 times of, now x squared y squared is actually xy raised to the power 2, right? But it's given, xy is given to be as 3, so this is going to be 3 raised to the power 2 is equal to 81. Now I'm going to rewrite this as x to the power 4 positive y to the power 4 is equal to 81 added with 3 squared is 9, 9 times 2 is 18. So I need to place that 18. So 18 added with 81, 8 positive 1 is 9. So I'm going to get 99. Of course on the left side, It's going to be x to the power 4 positive y to the power 4. This is what we've got. So let me move ahead. So now what I'm going to do is I'm going to be consider x squared positive y squared raised to the power 2. Now if I were to expand this is going to give me x to the power 4 plus y to the power 4 negative 2 times x squared y squared. It's actually positive 2 times x squared. Now why am I saying negative 2 times x squared y squared? Because I would want to use this system, or I would say this value which I just got here. I want to use this. So I'm going to rewrite this quantity as x squared positive y squared raised to the power 2 negative 2 times x squared y squared. Now what is this? This is nothing but x to the power 4 positive y to the power 4. This is what the entire system is. Now what I wish to do is I would have to use the value. Let me use the values. So this is going to be x squared positive y squared. Now this is raised to the power 2 negative 2 times. Now xy is already, we know the value of xy. So xy is going to be 3 and that has to be raised to the power 2. This is nothing but 99. Now 3 squared is 9. 9 times 2 is 18. So I'm moving the 18 to the other side. And that would be 99 positive 18. Now 99, let's check it out. 99 added with 18, 8 and 9, 17, 1 added with 9 will give me 10, 10 added with 1 will give me 11. So I get 117. So this is going to give me 117. On the left I've got x squared positive y squared raised to the power 2. Now from here I can extract x squared positive y squared. If I were to move this square to the other side, when I do that it will become a radical sign. So from here clearly I can write x squared positive y squared is equal to, when the 2 crosses over it becomes plus or minus root of 117. Right, so this is one side. So let me move on to the other side. So I would try to use this space here. Okay, there's some space over here. So let me use the space here. So what have we got? We have got here x squared positive y squared is equal to plus or minus root of 117. This is what we've got. Now using algebraic identity, I can rewrite this as x squared positive y squared. I can rewrite it as x positive y raised to the power 2 negative 2 times xy. I can do that. Now x squared positive y squared is this. So I'm going to place plus or minus root of 117 is equal to x positive y raised to the power 2 negative 2 times xy is 3. Now I'm moving the 6 to other side. So this is going to give me 6 plus or minus root of 117 is equal to x positive y raised to the power 2. Now I want to rewrite this as x positive y. I'm not going to move the squares as yet. I want to fragment this. So 6 plus or minus. Now 117 is nothing but 9 multiplied with 13. And I got a root there. So I'm going to rewrite this as 6 plus or minus. I can rewrite root of AB as root of A times root of B. I can do that. So with that, this is going to be 3 times of root 13. Right? On the left I've got x positive y raised to the power 2. So now I'm moving the 2. So that would be plus or minus root of 6 plus or minus 3 times root of 30. So this is the solution for x positive y. So students, thank you so much. I would like to encourage you all to think about other ways by which you can solve this problem.